Hello everyone and welcome to my lecture on resonance. First let us see what is resonance. In chemistry, resonance is a phenomena which describes the movement of pi electrons within the molecule or ion or radical. As a result of movement of this pi electrons, a molecule can be represented by two or more structures, and each structure is called resonance structure or canonical structure. Canonical structures are not the true structure. The molecule or ion or radical which undergo resonance can be truly represented by the combination of several canonical structures, which is called hybrid structure. Remember, resonance brings stability to the molecule. Resonance is also called mesomerism. But the first question that comes to our mind is that why the pi electron will move? Is there any driving force for the movement of pi electrons? Yes, we all know that the pi electrons are mobile. Pi electrons will move only if it is in conjugation with the multiple bond or in conjugation with the carbocation or carbanion or carbon radical or lone pair electrons. Look at the molecule A. It is a alpha beta unsaturated ketone. Oxygen is electronegative than carbon, so it pulls the electron towards itself and gathers a negative charge, and the carbon adjacent to it gains a positive charge. The moment the carbon gains a positive charge, the pi electron flows towards it, and A can also be represented by this structure. Similarly, in compound B, the pi electron is adjacent to a positively charged carbon. So, the positively charged carbon pulls the pi electron towards itself, and B can also be represented by this structure. Similarly, C has an excess supply of electron on one carbon, and this excess electron can be in conjugation with the pi electron, and C can be represented by this structure. D undergoes homolytic cleavage, and as a result of which D can be represented by this structure also. In E, the pi bond is in conjugation with a lone pair on nitrogen, which can be donated, and as a result of which E, when the pi electron is donated, it leads to the formation of a double bond here, and the moment it forms a double bond here, the central carbon becomes pentavalent. Carbon cannot be pentavalent. The moment this pi electron comes here, this carbon becomes pentavalent. Carbon cannot be pentavalent, so this pi bond immediately breaks, giving a negative charge on this particular carbon atom, and therefore E can be represented by both the structures. All these structures are called canonical structures. But canonical structures are not the true structure, because if you see a molecule, if you see compound A can be represented by all these three structures. At one point of time, A can be represented by this structure. At another particular point of time, A can be represented by this structure, and sometime A can also be represented by this structure. So, these structures are called canonical structures of A. So, A can have three canonical structures. B can be represented by two canonical structures. C by 2, D can be represented by two canonical structures, and E can be also represented by two canonical structures. But canonical structures are not true structures, because A cannot be represented by any one of this structure. Compound A is a combination of all these three structures, and that a combination of all these three structure is called a resonance hybrid structure, which represents that the pi electron flows from one end of the molecule to the other, and the oxygen in one of the resonance structure, in both the canonical structure, the oxygen is having a negative charge, and so the negative charge in the hybrid structure, the oxygen is having a delta negative charge, and carbon here in one of the canonical structure, the carbon is having a positive charge here. So in the resonance hybrid structure, it is having a positive charge here, and this particular carbon is having a positive charge in one of the resonance structure. So in the resonance hybrid structure, it is represented by delta plus. This carbon is not having any charge in any of the resonance structure, and so in the resonance hybrid structure also it doesn't have any charge. Similarly, compound B can actually be represented by this resonance hybrid structure, where the pi electron is flowing from one end of the carbon to the other. Positive charge is sometimes on this carbon, so delta plus, and positive charge is sometimes on this carbon, so delta plus on the other carbon. Let's look at the resonance hybrid structure for compound C. You can see that in the resonance hybrid structure, the electron is flowing from one end to the other. Negative charge is sometimes on this carbon, so delta negative here. In another point of time, the negative charge is on the other carbon, so that is represented by delta negative here. This is a resonance hybrid structure for compound D, which also shows the flow of electron from one end of the molecule to the other, and the electron, there is a radical sometimes on this carbon, and in another structure the radical is on the other carbon, so that is shown in the resonance hybrid structure. This is the resonance hybrid structure for compound E, where the electron flows from nitrogen to the carbon. The nitrogen in one of the resonance structure is positively charged, and so in the resonance hybrid structure it is represented by delta positive, and the carbon gains electron in one of the resonance, the terminal carbon gains electron in one of the resonance structure, and so it is shown with a delta negative charge in the resonance hybrid structure. I hope you understood how to draw the resonance structure. Here are some assignments for you. Draw the canonical structures and resonance hybrid structure of the following compounds. I am sure you will be able to draw the resonance structures of all these compounds. If you have any doubt, you can write on the chat box, on the comment box. And that's all for today's lecture. We will continue this topic in the next lecture. If you like my video, please subscribe and press the bell. I would like to end the topic with a thought. Every mountain top is within your reach if you just keep climbing. Thank you.